All right, so when we start with adding real numbers, we're going to just start with the easy stuff. So adding like positives and positives. And you'd be surprised because people will go, oh yeah, I remember there's a set of rules for these. And so they're like, okay, yeah, negative and negative is this, negative and positive is this. And then I go, what's a positive and a positive? And they go, I don't know. What's the rule? Like, that scares me because this shouldn't be a magic trick, right? So the idea is if I have a positive and a positive, for instance, if I have 3 plus 8, 3 plus 5, there I go thinking about the answer. 3 plus 5 gives us what? Yeah, why? Well, it's saying start at 3. There's two ways of thinking about it. It says start at 3. So if this was 0, we would go 1, 2, 3. And then from there, add another 8. I'm sorry, freaking A. Add another 5, right? That means go 5 more, and it's positive, so 5 more to the right. And I go 1, 2, 3, 4, 5, and I end up at, does that make sense? So when I'm adding or I'm subtracting, we're going to the right or going to the left. Now this gets a little more complicated as we keep going, but this is our basis of knowledge. I understand that if I add a positive plus a positive, I get an answer that is positive. Okay? Another way of visualizing it, and this is actually what I prefer, is thinking of balancing positives with negatives. Okay? So for now, I'm literally just thinking about if I have 3 positives and I have 5 more positives, that they would combine. When they're the same sign, they will combine. I now have 8 positives. Nothing gets crossed out. A plus 1 and a plus 1 makes 2, right? So this is actually, and it's not practical. I'm not going to keep drawing positives and negatives with every number. If I got 100, I'm not going to draw 100 positives. But to me, it's just as difficult to be jumping around the number lines when they're really big. So visualizing it with pluses and minuses, to me, is a better way of comprehending what the answers are here. Okay? What if I had a negative plus a negative? I can do the number line. I can sit there and say, well, if I start at negative 3, there's that starting point, right? And I'm adding a negative 5, means I'm going what direction? So 5 more to the left. Adding a negative is basically adding more deficit, going further to the left. So if I now go 5 more to the left, I end up at what? Positive 8 or negative 8? See, positive 8's way over here. That makes no sense, right? People are like, I don't know. And if you're thinking it became positive, you're thinking about the rules of multiplying. And once again, I know there are rules for this, but these rules should make sense and not be magic tricks. Okay? So if I start at negative 3 and I go 5 to the left, I end up at negative. That's a perfectly fine way. Once again, if the numbers get bigger, then it's not as practical. But I can make the same argument and say, if I have 3 negatives and I have 5 negatives, and if they are the same sign, they will, what's the word? Yes. Anytime I add a negative and a negative, I get more. That shouldn't be something that scares you. And you're like, yeah, but sometimes it's positives. Quit trying to memorize tricks. Think about it this way. If I owe you 3 and I owe you 5, do I all of a sudden have $8? Doesn't work that way, right? When I owe you and I owe you more. Those debts, those negatives combine to give us a larger negative. So what do I do if it's positive or negative? Right? A positive plus a negative or a negative plus a positive? Well, let's look at the first one. If I did 3 plus negative 5, so that basically says I'm starting at 3, right? And I'm going negative 5, means I'm going 5 to the, right? If I go 5 to the left, 1, 2, 3, 4, 5, where do I end up at? Did those combine? No. Once again, this is not my favorite because I don't want to be jumping on back and forth across the number line with really big numbers. What I prefer to do is visualize, look, if I have 3 positives and I have 5 negatives, They don't combine. There's another C word for that. They see, every time I have a +1 and a -1, if I owe you 1 and I give you 1, that cancels out the debt, right? Every time I have a plus and a minus, they basically cancel each other out. But that didn't cancel everything out, did it? I still owe you. I owed you more than I gave you, right? I owed you 5, I gave you 3. I still owe you what? I still owe you 2. I like that better. Because then what I can do is if I know that the same sign combines and opposite sides cancel, then I just got to figure out which one do we have more of. See, why was this one negative? Because we had more negatives. 5 was more than the 3. In fact, how much more was it, right? It was 2 more. A lot of times they'll say take the larger, when they're opposite sides, you take the larger number minus the smaller number, and then basically we keep the sign of the larger number because that's how much we had more left. That's great, but if you're just using it as a trick, that scares me. Okay? But yeah, definitely if I had 3 plus -5, I would do 5 minus 3 is 2. How do I know that that 2 is negative? Because we had more, which means what really? We had negatives left after everything was canceled out. What's going to happen if I do -3 plus 5? I mean, on the number line, we're going to jump past the 0, which means it's going to become positive. But like I said, my experience is that that gets really complicated with big and smaller numbers. So I would rather visualize 3 negatives, 5 positives. Are they going to combine or cancel? Opposite signs, they're going to cancel out, leaving us with what? So it's still the same 5 minus 3, but the difference is we had more what? More positives, which is why we had positives left over, which is why it's a positive. So what is it? If it's a positive or a negative or a negative or a positive, what's the answer? It matters. On what? Whichever is the larger, we keep the sign. Why? Because when everything cancels, that's what we're left with. Does that make sense? When everything cancels, the one that was larger is what we're left with. We were left with more positives. We were left with more negatives. Here's an extreme example. What if I have 20 plus -1,000? Right? I got $20 in my account. I take out 1,000. What just happened? I overdrew, right? I took out more than I had. How much more? How do you figure out how much more? You take the larger number, which is the... And I know that numerically the 20 is larger. It's further on the number. But I'm saying which is the greater. The greater is the positive greater is the 1,000. It gets confusing with our conversation in the last sections, but basically the larger number is the 1,000. Okay, so we have 1,000 negatives. I am not drawing out 1,000 negatives, right? But from those, I'm going to cancel out 20 what? I'm going to take away or cancel out 20 positives. And what am I left with? And why is that 980 negative? Because after we canceled out the positives and the negatives, we were left with 980 more what? Negatives. Okay? Now some of you have already started the homework on this. I'm just trying to justify there should be some reasoning behind this. We're not just making this a magic trick, but let's be clear. I have technology. I can do, right? What was it? 20 plus. Make sure when you do plus a negative, there's a different symbol for the negative. It's this, for me, it's this minus with the parentheses on it. You can even put it in the parentheses just like it was set up. Negative, what was it? Negative 1,000, right? And this will not combine them. This will cancel them out, leaving me with what? 980. Make sure you know how to use your technology. I'm not asking you to do all these by hand. Yes, we should understand why the answer is what it is. There needs to be some number sense to this. But you have access to the technology. Is that correct? Okay. We all right on this? Let's continue. So for these crazy number of examples, are we going to combine or cancel? Why? Same sign combines. What about B? Opposite signs? You see how this is working? Next one, the signs are, so they will. Next one. Next one. It's a little weird. They are kind of opposite signs. We think of cancel. That's kind of a weird one. We'll talk about that. What about our last one with fractions? If I have 12 negatives and I add 7 more negatives to that, what will those combine to make? Can I do that in my calculator? But it should make sense. If I have negative 1.4 and positive 8.5, will they combine or cancel, right? And I could take, which of those is the larger of the numbers? We have a greater positive this time, right? Isn't 8 more than 1? So really, in my mind, this is the same thing as 8.5 minus 1.4. And I hear some of you right now, putting it all in your calculator. That doesn't hurt my feelings. And I just destroyed my screen. But that doesn't hurt my feelings. But I can cancel these and tell you that leaves me with 7.1. Does that make sense? And I'm okay if you want to use the technology. But this tells me I'm going to be left with 7.1. 7.1 positive or negative? Because we had more positives, that's what's left, is the positives. Make sense? I am not drawing 7.1 plus signs. It doesn't work that way. But it should make sense when it's easy so that I can apply the same rules when it gets more difficult. Okay? 36, negative 36, positive 21. We said they're going to cancel. If I was doing this logically, what number would go on top? And I'm going to take away 21. That's weird. It seems counterintuitive. But remember, the word here is to, and isn't canceling a way of like taking away? We're taking away 21 positives and 21 negatives. We're canceling them out. And that leaves us with what? But the answer isn't 15, is it? Why is it negative 15? Because we had more negatives, so that's what we're left with. Could I type that in my calculator and it'll tell me negative 15? But there should be some sense behind it, okay? What about negative 1 or positive 1.5 and negative 1.5? See, that's where they're identical, right? If I subtract them, I'm just left with. What if I add 0? What happens if I add 0 to something? Yeah, I wouldn't even, I mean, I got why you put cancel because there was a plus there. I would say whenever you add 0, it just stays the same. So it's just what? Any questions on that before we continue? And last one, 2/3 plus negative 5/8. Do you know how to add fractions? Do you need to, 8 and 3, give them a common denominator of 24 and all? You can do all that, can't you? Do this one, and now I have 16 over 24 plus negative 15 over 24, right? Yes. Oh, this is an 8. It looked horrible, doesn't it? It does look like a G. No, it's an 8. No. Yeah, no, we're not there yet. No. No. Yeah, I throw a letter on the screen, all these little puddles around the room with people with like tears, and yeah, it's all right. Now, we said these were going to cancel. Are they still going to cancel? Right? And when they cancel, 16 minus 15 is what? Is it negative 1 or positive 1? Because we had more. Now let's be clear. 2/3 plus negative 5/8, right? 2/3 plus parentheses negative 5/8 would be how I type it in. Mine gives it to me, but we need to be comfortable going from the decimal to the fraction. So menu for me, what is it? Number, there it is. Write that as a fraction for me. Oh, that sucks. What just happened? I think we just broke my calculator. Interesting. All right, I'm going to mess with my settings because my settings, I actually can have it give it to me as a document. Normal, approximate, make it auto. Let me try that again. How about that? Does that look a little better? That just shows you the limitations of the calculator. It rounds off things even though it goes really far, it's not exact. So be careful. You've got to be smarter than your calculator. Yes?
Is there a way that, okay, so say that just the 5 is negative and not the 8.
Mm-hmm.
So on mine, I feel like it's making the whole fraction negative.
You can have the negative. You could write this as 2/3 plus, like you could put the negative up there with the 5. Or you could write that as 2/3 plus and have the negative outside the fraction, and it won't change anything.
So it's just a matter of playing around and figuring out.
I saw some of the examples where they put the negative on the bottom, which is weird. We won't do that. We always keep the negative on the top or on the side, but these two say the same thing.
Okay, because it looks like all of this is negative, but
Yeah.
I still got 1 over 1.
Yeah, that'll be fine. Good questions. All right, can we continue? What if I got all this mess?
And you have to clean it.
Now, in the past, we've gone just from left to right, and that doesn't hurt my feelings. I could go 15 minus 2 is 13 plus 20, 34, and I'm just jumping back and forth across the number line. But there's an easier way, and there's a property which we have reviewed called the, what is it called? The commutative property. You don't have to, but we can add these in any order. So the commutative property basically says commuting, I can change the order. I can add in different orders. So wouldn't it be a lot easier just to add the positives with the... Could I do that? What is 15 plus 7 plus 14? 36. And wouldn't it be easy to add all the negatives with the negatives? Because they're just going to, what's the C word? They combine when they're the same side. So what's 2 negatives and 5 negatives and 12 negatives? Mm-hmm. And so now what I can do is just cancel. Now up here I write combined. And down here I can cancel what's left. 36 minus 19 I think is 17. And is it a positive 17 or a negative 17? Because we had more. Does that make sense? Okay. I could type all that in and hit enter and it should tell me 17. But there is some logic that we could do with this as well. Is that okay? What if it's decimals? I would do the same thing. So I would add, I probably would just type all that in. But if I had negative 0.9 plus 0.16, I probably wouldn't do it. I would combine the negative and the negative, which would make negative 0.11, and then plus 0.16, and then I don't even need to write the plus 0, it didn't change anything. So that's one of those, I wouldn't even worry about it, or I could combine those two and they would just become that, right? And so now I owe somebody 11 cents, I've got 16 cents. What am I left with? I don't put it in your calculator, doesn't hurt my feelings. 0.05. I got 5 cents. Positive or negative? Because I had 16, I lost 11, I have 5 left. Still positive. They cancel each other out there. Okay? Not completely, but the positives and negatives cancel. Okay? Now, here's what happens, and this is an irritant of mine because I've been teaching this for a long time. And I will have students that if I just gave you all a test right now on adding, I guarantee we'd have about a 90 to 95% average in my classes. It's just, I mean, we all make mistakes. You've probably seen me make mistakes today. But the issue is when we get to subtracting real numbers, all of a sudden, and this has happened in the past, I used to test them separately I wanted to collect this information. I'd have like a 90 to 95% average on my adding, and then I get like a 60% average on the subtracting. And I was like, oh crap, we got a problem here, right? And what irritates me is because the way I teach subtracting real numbers is to turn it into adding. That's really our only step. And this is a skill, whether you're using your calculator to do a lot of this or not, you need to have this skill, especially as we get into the algebra, how to change the subtracting into adding. Why do we want to do that? Because if I can learn that one step and change it from subtracting to adding, all of a sudden I made the question very easy. The adding is a piece of cake, 90, 95% average on that test versus a 60%. So if you can learn that one step, you turn this skill into something much easier. Make sense? We know that 9 plus negative 5 is what? 4? 9 positives. Oops, I don't need to write the 9. 9 positives. 5 negatives. And they are going to, and when they cancel, I'm left with 4 more positives, right? What if I argued that that is the same thing as 9 minus 5? Would you agree or disagree? What you just told me is that A plus negative B is the same thing as just doing A minus B. And vice versa. This arrow goes both ways. Like, okay, so why do I care? I'll show you, just be patient. Here I have A minus B, right? I know that's the same thing as A plus what? Plus a negative B. What did we just do? We changed it from a subtracting question to a... And you may not have to do this for all the questions. I hope you don't. So for instance, if I gave you 9 minus 5, I wouldn't change that to 9 plus negative 5. I know the answer doesn't change, but to me it's easier just to do 9 minus 5. Agreed? Where I freak people out is where I say 1 take away 5. And we go, oh crap. Right? And this is one that a lot of you can do in your mind that doesn't hurt my feelings. We're going to get to some more complicated ones, but I want to make the argument that 1 minus 5 is the same thing as 1 plus what? And if 1 plus negative 5 is negative, then what should 1 minus 5 be? The answer shouldn't change, should it? In fact, some of you don't believe it unless the calculator tells us. So let me get rid of that. That's terrifying. So let me do 1 minus 5, right, is the same thing as 1 plus a negative 5. Can we agree on that? And somebody's looking at that right now and going, I don't need that. I can do 1 minus 5 and visualize in my mind negative 4. Don't worry about it. We'll get to one that'll help you, okay? But I want to agree, this works right now, right? Okay. What about negative 3 minus 5? That's where I start catching people. They're like, oh, crap. Start at negative 3, go back to 5. I can visualize that still. That doesn't hurt my feelings. But if that scares you at all, then learn how to change it from a subtracting to a... So negative 3 minus 5 would be the same thing as negative 3 plus... See, to me, there's no doubt in my mind what negative 3 plus negative 5 is. If I have 3 negatives and 5 negatives, they combine to make what? You're thinking about multiplying again, right? The 2 negatives combine to make a bigger negative. Okay? So that negative 3 minus 5 is also negative 8. There are people right now going, I didn't need to change that. And I'm going to argue one thing with you real quick. If I told you negative 3 minus 5 and you knew it was negative 8, in your mind, you're changing it. Just because you're not putting it on the paper, in your mind, you're thinking of it as negative 3 and negative 5, and you're combining them to make negative 8. You may not be formalizing it on the paper, but that's what you're doing. Is that all right? What the hell am I going to do with negative 3 minus negative 5? Freak out, right? Because this is like, how do I start at negative 3 and take away a negative? This is complicated. Really hard to visualize, right? But I gave you a process that works when it's easy and will work when it's... So if I can change subtraction into adding the opposite, then negative 3 minus negative 5 becomes negative 3 plus a positive 5. Some people have heard this, and I've heard songs and dances and all that. Some people call this like a stay, change, change. If that helps you, feel free to use it, okay? But the first term stays. The subtraction changes to adding, and then the number changes from a negative to a positive, okay? But subtracting is the same thing as adding the opposite. So if I have minus negative 5, that's the same thing as negative 3 plus 5. Will those combine or cancel? Come on, we're back to the easy stuff. Negative 3 plus 5. I've got 3 negatives and 5 positives. Are they going to combine or cancel? And if they cancel, I'm left with, I heard 2 more what? And guess what? The answer is also 2 on the other one. Can I put that in my calculator? Can I put negative 3 minus a negative 5? And the calculator is going to go, oh my gosh, this is crazy. I can't do this. No. It knows that that's the same thing as doing negative 3 plus 5. Does that make sense? Know how to change these. Because I'm telling you, I've done this for years. If I gave the adding test 90 to 95% average, if I give the subtracting test a 60% average, because people are like, oh crap, what's the rule for that? Learn how to change it from subtracting to adding so that you can bring that percentage up. Okay? And learn how to use your technology. That doesn't hurt my feelings, but there should be some sense behind it. Okay? Somebody, and we were having this discussion before, somebody was using the rules of multiplying here to know that those kind of a negative times negative is a positive. That doesn't hurt my feelings. I just don't make that argument yet because we haven't got into the rules of multiplying yet. Okay? And I don't have to use the rules of multiplying to justify that. So just different ways of thinking about it. But basically, if I have, kind of these are my general notes here, okay? If I have A minus B, I can change that to what? A plus negative B. And if I have this crazy A minus a negative B, the minus a negative can change to a adding the opposite. And I can change any subtraction problem into an addition problem, which makes it easier. Okay? Can I scoot it down? Okay. Coffee break. It's not very good. You're not missing anything. No. All right. 2 minus 6. I don't need the answer. I can put that in my calculator. How would I change that if I needed to? There you go. I can visualize that. 6 negatives, 2 positives. Cancel them out. I'm left with what? A lot of people mistype that and end up getting the answer as 8. That should stop you. Like there should be some number sense. There's no way if I have 2 positives and 6 negatives that I end up with 8, right? This should stop you. There should be some number sense here. 4 minus negative 9. There's that terrifying thing, right? We change it to what? I will have some people, and if you prefer to do this, it doesn't hurt my feelings, they'll take the minus the negative and change it to a big old plus sign. It's not wrong if you prefer to do that. The 2 negatives multiply to make a positive like that. A couple ways of thinking about it. That's just not the way I do it. But that doesn't hurt my feelings, okay?
So the first number, it stays the same, but the second one changes.
Yeah, and it's because the first number we're not doing anything to. What we're doing is we're changing the operation from adding to subtracting, which changes the second number. Okay? Negative 4.2 minus negative 3.6. The numbers got more complicated. Does that mean we start making up new rules? The rule stays the exact same. So what is this the same as? Negative 4.2 plus. Are those going to combine or cancel? And if they cancel, I'm left with, because I can subtract the big number minus the small number and get 0.6. Somebody's telling me that's not my answer though. Why? We had more, so the answer should still be negative 1.8 minus 7.5 is the same thing as Are those going to combine or cancel? Same sign, combine, right? So I'm looking at 8, 9 point. I can add that in my head. What about the sign? Stays the same. And if it's a fraction, all the rules change. What is 1/5 minus negative 3/5? I don't need a calculator for that. It doesn't hurt my feelings if you put that in a calculator. Those already have a common denominator, don't they? What is same sign? They're going to combine. What's 1 plus 3? Two sections down. Is the adding easy? Is the subtracting easy? It gets weird though, but when you learn to change it, it makes that section just as easy as the first one. One extra skill to add. Fair enough? Can I keep going? And in all of this, you have your technology. That doesn't hurt my feelings. Get comfortable with it, but you shouldn't depend on your technology to be your brain. There should still be some number sense here. You thought you were done. What if I got a whole mess? This looks terrifying. Is there anything in here we can change? Short answer is yes. The subtracting is more complicated, isn't it? So anywhere I see subtracting, we can change it. So I can write this as 8. What's minus negative 4 become? Change. Plus. What is minus 2? Now maybe you don't need to change that. Maybe you leave it as a minus 2. I'm going to change it. Subtracting 2 is the same thing as adding what? So I can change the entire question from a subtraction problem to an addition problem. What does minus negative 5 change to? And what about the plus 3? It's already adding. I'll have people change, literally, they'll go, oh, okay, change that to minus negative 3. I'm like, what the heck? I mean, it's true, but do you really want to do that, right? It's already adding. Leave it alone. The whole point of changing it is not just to change it, it's to make it easier. So I think this is a much easier question than what we started with. Can we agree? Do you see anything that are the same sign? Positive, 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 positive. What do all those add to make? I think I got 20 if I'm right, but I'm not always right.
Yeah, 20.
Is it 20? So now I've got 20 plus, which is There you go. And it wouldn't have hurt to leave that as 20 minus 2, but I'm just showing you we could change it. Okay? What do I do here? We got variables. We combine like. So that means I combine the A's with the B's with the, and the 10, or the constant, with any other constants. There aren't any. Leave the 10 alone. What is negative 5 minus 4? Now, I just skipped a step, but that's the idea, is that once you do this enough, it should make sense. I know negative 5 minus 4 is negative 9, because in my mind that says negative 5 plus negative 4. Okay? Could I do that on my calculator? But the idea is that we should have some sense. What is negative 7 plus 10? So I'm left with 3. And then what do I do with the other 10? What do I do with that 10? Just bring. It doesn't combine with anything else. The constants can only combine with constants. The variables with the variables. I know, it sounds all like racist. She's all segregation. Jeez. The A's don't talk to the B's. Not after what that bee did. Tell you what. All right. These are the jokes. I'm not saying they're good. That's the best I got. I know. Thank you. Next example. What will combine with what? I heard the 4 with the 9. Those are both constants, right? What else? Now, it doesn't hurt my feelings as far as order and at this point with what we're doing, but a general rule is that we put the variables first.
But it doesn't make a difference.
It doesn't make a difference. It will matter later on. There will be times where we want to. Better to get used to that habit, absolutely. So I'm going to do the variables first. So negative 3 plus 2 is what? Somebody else is going to just write that as negative m. Is that wrong? No. Negative m is the same thing as negative 1m. Both are correct. Now, whether they're both correct to Alex, I can't guarantee. 4 minus 9. There you go. I would accept either of these answers. I would also accept if somebody put the negative 5 first. It wouldn't hurt my feelings. It's not my favorite way of doing it, but it's not wrong. I would also accept if somebody wrote this as, I forgot the 1 on that one. Sorry about that. I'm just trying to show you mathematics really is not super restrictive. All of these say the same thing. And so all of those would be correct. Does that make sense? So don't be mad if you're like, I would have just left it as a plus negative 5. Awesome. That is not incorrect. That's a perfectly good way of doing it. Okay? So we have some options with mathematics. Is that okay? Out of all these would be the ones I'd prefer, but the other ones are not wrong. Let's keep going. With multiplying and dividing, there's another like logical approach to this. There are rules for these. That doesn't hurt my feelings. You can write these rules down, stick them on a note card. That's fine. You can let your calculator do the heavy lifting to remember those rules. That's fine. But there should be some logic. Like I know that 4 times 5 is what? I'm going to argue that a positive times a positive will always be always. Because if I were to add 4 5 times, it would equal 20. Can you agree with that? If I add 4 5 times, it's 20. What that does is it helps me rationalize the next one, which says, what if I added -4 5 times? I know that 4 times 5 means the same thing as 4 plus 4 plus 4 plus 4 plus 4. Adding 4 5 times. Agreed? This basically means the same thing as what? What is -4 plus -4 plus -4 plus -4 plus -4? Will they combine or cancel? They combine, don't they? In fact, 4, 4, 4, 4, 4, they all combine to make what? Negative. This to me is an argument telling me that if I have a negative times a positive, it will always be what? Always. Any questions on that before we continue? This is where this little analogy kind of starts to fall apart, because if I have -4 times -5, how do you add something -5 times? It gets weird. But this is a good foundation for a positive times a positive is always positive. You'd be surprised, people are like, oh, this is a great trick. They get these tricks and they go, oh, negative and negative is positive. I'm like, okay. And then I'll ask them, what's a positive and a positive? And they're like, negative. I'm like, are you freaking kidding me, right? This should not be a magic trick. Okay? So this is kind of my foundation, but this I'm going to take it a step further to help us when things get a little more complicated. I'm going to argue that a negative is a way of saying the opposite of that number. Some of you don't believe me. You're like, it doesn't make sense to me. What is the opposite of 9? What the hell? You just put a negative in front of it. Didn't you? Opposite is to stick a negative in front of it. Make it opposite, right? Now watch this. What's the opposite of -9? But you just told me I could put a negative in front of it, and that means opposite of, right? So you're telling me that the opposite of -9, which you're like, it's 9, is the same thing as saying, what is -9? That says, what's the opposite of -9, doesn't it? You don't like my argument. That's okay. It's just a different way of thinking about it. If the opposite of 9 is -9, I put a negative in front of it, then the opposite of -9 is -9. Agreed? Sure. Which we already said. We know that's just +9. When I multiply a positive and a negative, the result is always what? 4 times -5. 4 times 5 is 20. There is one negative, makes the answer. When there's one negative, 4 times -5, one negative makes our answer negative. What if I have a negative times a negative? Why? I love it. She said a negative times a negative is positive because a negative times a negative is a positive. Okay? I do like that, but no. Because the opposite of a negative is always, and so if I'm multiplying two negatives, then I'm getting the opposite of a negative, which will always be positive. This first one says the opposite of a positive. There's only one negative. The opposite of a positive will always be negative. This one says, what's the opposite of a negative? Always. That's my favorite argument for this. You may not like it, but that's my favorite way of dealing with it. So that if I have -4 times -5, I still get the same 20. But this time the negative and negative make that 20 positive. Fair enough? What if it's a fraction? Right? Run for the hills? No, we dealt with that already. What is -1/3 times 5/7? You can put that in your calculator and hit enter. I also know to multiply fractions, we multiply straight So what is 1 times 5? What is 3 times 7? And it was a negative times a positive, which is what? Yeah, I can answer these faster than you can type them in your calculator. There are times to use technology and there's times to use your brain. Both should agree. Both should get the same answer. Okay? And I'm not taking the technology out of your hand yet. I'm just kidding. I'm scared like half of you. That's funny. That's awesome. All right. What is a negative times a negative? 2 times 1. 3 times 3. The homework will not like you putting the positive there. That's just my way of showing that it changed. But yeah, really they're wanting 2 9ths. They'll look at you like you're stupid if you put the plus in front of it. I like to do it visually when I teach it. Sorry. So I wouldn't mark you off. I'm a little more lenient, but the homework will be like, what are you doing? Okay. Example 2. What is a positive times a negative? 1 negative makes it. 1 times 3 is? 8 times 4? 32. Very good. What's a negative times a positive? 2 times 9? 3 times 2? Ready for the next one? No, I got to be smarter than the technology, right? Be careful with this, please. Are you going to leave 18 over 6? No, this can be simplified. A couple ways of thinking about it. Can you think of a common factor? I heard 2. This is probably the loudest one I heard. Gives me 9 over 3. Still negative. Am I done? No, they're still both divisible by. I'm okay with that answer, but really, what is negative 3 divided by 1? That's the early answer I'm looking for. And if you didn't catch it, look, 18 divided by 6 is just 3, so it would just be a negative 3. Different ways of thinking about it. Is that okay? So yeah, you still need to know how to simplify these, and if you know how to cross-cancel things, why that works, that doesn't hurt my feelings either. If you have no idea what you're talking about, multiply them straight across and simplify them, or use your technology. If I multiply the last one straight across, oh my gosh, you get this wrong, it's some tears down my face. What is the positive times the positive? There's no magic trick for that. That should make sense, right? 8 times 5 is? 3 times 10 is? Do not leave your answer like that. Top and bottom are both divisible by, leaving me 4 over 3. I'm okay with that. They may want you to make that what? The 1 1/3. So be careful, for both could be expected. None of this is new except for the integer aspect of it. Fair enough? See, a couple of you still writing, and I'm also going to address one thing about the rules again before we move on. So if you're just writing through example 3, you're fine. I'm going to jump back up to the rules real quick, okay? Which is this, real quick. Right here and right here. A negative times a positive was negative, and a positive times a negative was also negative. Did we say it matters which one's bigger? This is not adding and subtracting, is it? I'll have people go, oh, look, the 5 is bigger. It's positive. One negative makes everything stay negative. It doesn't matter which one's bigger. We're not adding here. We are multiplying. Different set of rules. Okay? Did it matter down here that the 5 was bigger? And that's why it's negative? No. One negative makes the answer negative. 2 negatives makes the answer positive. That's going to matter right here. Well, we're coming up to it. What about decimals? 1 negative makes the answer what? 1 negative makes the answer what? What is 1.2 times 3? There you go. I can do that without a calculator. La-di freaking da, right? Use the technology. It doesn't hurt my feelings. The next one has multiple steps to it. There's a couple ways of doing this. I can go from left to right and start with what is -3 times -2? And what's a +6 times a -5? Now there's one negative left, right? Makes the answer. Doesn't matter that the 6 is bigger. We're not adding, we're multiplying. Different set of rules, okay? That is not how I would have done that. I would have just saw this. How many negatives were in the original question? Every 2 make the answer positive, right? So these 2 would make it positive, which they did, and I would be left with, if there is ever an odd, well, here it is right here, an odd number of negatives, the answer will always be, why? Because every pair of 2 of them multiply to make it what? And then that one that's left over makes the whole thing turn. Does that sort of make sense? I would have just done 3 times 2 is 6, 6 times 5 is 30. There were 3 negatives, so my answer is negative. Choices. Some of you are like, I would have typed that in my calculator. Thank you. Okay? Why do I say that? Well, look at the next one. You can start pairing them up. You can pair the -4 and the -6 to make what? Negative times negative, I heard +24. Would you pair up the other ones, or would you bring them down and keep going? It's up to you. What'd you say? All right, if you pair them up, what's -1 times -2? Now I have a positive times a positive. What's 24 times 2? I wouldn't have done that. I would have seen how many negatives are there? 4 negatives. An even number of negatives means the answer will always be. Why? As they pair up in groups of 2, every time I have 2 negatives, it'll change it to a. So if there were 2 negatives, it'd be positive. If there was 4 negatives, it'd be positive. If there were 6, 8, 10, if there's an even number of negatives, it'll turn into a positive. Fair enough? We're almost done. What is 173 times -552 times 0? What is 173 times -452 times 0? Yeah, you're wasting your time if you're typing that in your calculator. You can. But the minute I multiply any number of times, the whole thing will equal. This is called the zero product property. Basically says anything times 0 equals 0. Anything times 0 equals 5 times 0, 8 times 0, -53 times 0 is still 0. A stands for any number times 0 gives us 0. So I can have all this mess, but the minute I multiply it by 0, done. We've done adding. We've done subtracting. We've done multiplying. How about, ready for this? This is the most exciting thing in the world. Do you know how to multiply? Do you know how to divide? Do you know the rules for multiplying? Then you know the rules for dividing. Division of negatives is the, meaning what? A positive divided by a positive is, freaking tell me that's negative, I'm going to be mad, right? This makes no sense. We've never done that before. 10 divided by 2 was always 5. I never needed to worry about the sign. Don't start changing the rules here, okay? Where does it get different? If I have one negative, it makes the answer. We actually already had an example that did that where I was dividing with a negative. If the negative's on the bottom, it doesn't matter. The answer will still be. If there's one negative, the answer will be negative. If there's 2 negatives, it will be positive. There's ways of justifying this, but if you just keep it as the same rules, it'll make your life easier. But there are ways of justifying this. 14 divided by -7. How many negatives are there? 1, right? So the answer is going to be, and what is 14 divided by 7? Right? The next one, negative 32 over negative 4. What does that over mean? It means division, right? We are dividing. How many negatives are there? A negative divided by a negative is, and 32 divided by 4 is, bingo. The argument for this, to justify it, and I'm not as worried about this, is that I could make this, isn't negative 32 the opposite of 32? Like, it's weird, but isn't negative 32 the same thing as negative 1 times 32? Isn't negative 4 the same thing as negative 1 times 4? Whenever I have a negative over a negative, those cancel, don't they? The negative 1 over negative 1 will always cancel, so that my ending answer will always be just a justification, if you care. There's one. What is 0 over negative 3? What is negative 3 over 0? I always do this. This is called, there's two ways of thinking about why it's called undefined. The first one is if you think about division properly, and by the way, some of you putting in your calculator right now are going, oh, I got it. Yeah, it's going to. Okay. But I always thought of fractions as, right, we have this much, and we are dividing by whatever we're dividing by. So we're dividing by, or we're pulling out groups of. Okay, so on the top one over here, I had 14 divided by 7. I have 14. I can pull out 2 groups of 7. Literally, I could logically do 14 divided by 7 and go, that's 2. I pull out, I have 14. I'm dividing by 7. There are 2 groups that come out, right? This one says, I have nothing. How many groups of negative 3 are there? That makes no sense. You have nothing. There are no groups, right? Why is this one such an issue? This one says you have negative 3. How many groups of nothing do you have? What the heck does that mean, right? How do you pull out groups of nothing? I can understand having nothing, but how can you pull out groups of... See, this is craziness, right? There's a better explanation than this if you don't like what I just said. So let me show you real quick, okay? Watch this. What is 8 divided by 2? And we're not in, like, second grade, but this is what they do in second grade when they're teaching basically the multiplication division rules. 8 divided by 2 is 4, and we can check it because what? Whatever number goes here, I can put into the multiplication statement and it should be true, right? So what goes right here? And we did this in like first, second grade, and we got our little golden star and we moved on. But you had no idea this would apply to zeros and justify why it's undefined. Watch this. What is 8 divided by 0? Somebody thinks it's 0. Okay. Is 0 times 0 8? Oh. Oh, is 8 times 0 8? Would 8 work here? Is 8 times 0 8? What number can go here? What number can go in both these boxes? There's no number that works for this, right? There's no number times 0 makes 8. You're like, then why don't they just write no solution? Because of this last example. What is 0 divided by 0? She thinks it's 0. Is that right? Well, would it work? Does 0 times 0 make 0? Well, isn't 0 times 0 0? That works, doesn't it? She's not wrong. The problem is she's only gotten one answer. There's other answers that go here. What if I argued, and most generally what people will do is they'll say anything divided by itself is what? Does 1 still work here? Does 2 work here? That's where it gets weird. But doesn't it work? 2 times 0 is still 0. 3 works. 5 works. 20 works. This is freaky, right? See, up here we're like, yeah, 4, that's it. Here nothing works. Here what? Any number works. That's why. Why don't we divide by 0? It breaks our mathematical rules. It doesn't work. Depending on the example, we either get no solution or any number works, which is why we call it what? Because it doesn't fit our defined rules of multiplying and dividing. So it's an undefined rule. That make sense? Short answer is don't divide by 0. And no, you don't have to have that memorized. Stick that in your calculator. It will freak out. Don't divide by 0, right? It'll like throw all these expletives at you and all these bad words and be like, what the freak is wrong with you now? Don't divide by 0. Okay. Do you know how to divide by fraction? We've learned this, right? This is the same thing as negative 2/3 times what? Could we do that? Multiply it straight. Negative 2 times 3 is negative 3 times 1. Can we simplify that? We could have canceled. That doesn't hurt my feelings at all. What is negative 6 divided by 3? Positive 2 or negative 2? There was one negative, right? Makes the answer. Could I have done this in my calculator? You can. It gets a little trickier. What was it? Negative 2 over 3. Then you got to go like divided by the group. What was the second one? No, you're scared. 1/3, right? That's right. Divided by 1/3, and it'll work, but it gets a little weird to try to put that in your calculator. I encouraged you when you're dividing fractions to know multiply by the reciprocal. Okay? So that negative 4/5 divided by negative 7/3 is the same thing as what? Times? That's interesting. You move the negative to the top. We would do that actually. You can put the negative on the bottom. It will not change the answer. But stylistically, we always keep that negative on the top. That's just, when I'm dealing with fractions and common denominators, it doesn't matter if the negative's on the top, on the bottom, on the side, but it's easier to keep it on the top or on the side. We never leave it on the bottom. Okay? Multiplying those straight across. What's negative 4 times negative 3? What's 5 times 7? And I believe we're done with that one. The justification for this, we've had this discussion before. So this, if you want some justification, why can I just multiply by something that flips? Is this looks terrifying, doesn't it? This looks terrifying. But this is the same thing as this. Aren't these the same thing? They say the same thing. I don't want to do this. But I can get rid of this 1/3 by multiplying the bottom by. Then I get 3 over 3. Literally, that bottom fraction is gone, right? But I can't just multiply that to the bottom. With fractions, what I do to the bottom, I do to the... So notice what happens. The bottom goes away, and I'm left with this line. That justifies it. If you don't like that, that's why we multiply by the reciprocal. Okay? You can always do that. To clear division, we multiply the right by the reciprocal, and it gives us the same answer. Okay? Let's see if you can use your calculators. If you want to type that in your calculator, that doesn't hurt my feelings. If you're not liking the division by fractions in your calculators, I get that. Can you help me turn that into a multiplication question? Perfect. Take a second, put that in your calculator, tell me what you get. That's what I heard. Make sure you can get that, because these questions aren't going away. What about the next one? It flips. I'm okay if you don't know how to simplify that. That doesn't hurt my feelings. I think I have, is it 5 over something? Practice right now. Put that in your calculator. What do you get? This is what I heard. Make sure that's what you get, right? Also make sure that, could you write that as a mixed number? I can ask for either of those. That's all fair game, right? Last but not least, verify that you can do this in your calculator. I don't need to do a whole multiply and reciprocal this time. It's just a decimal, right? 27.9 divided by -3. I know, because of the rules, I know that a positive divided by a negative is, so I don't just check out my brain. But then 27.9 divided by 3 should give me 9 point. There you go. The rest of this shouldn't be anything terribly new. We just have a couple things to clean up that will show up in your homework. But to me, these are the big 4 topics on real numbers. Can you add, subtract, multiply, and divide? Do you know when to combine like terms? That's what we're starting with, right? The rest of this is just dealing with exponents, which we've done before, and then some order of operations stuff, okay? We're almost done. You're like, I hope so. Class is over here soon. Feel free to do these in the calculator. It doesn't hurt my feelings. But what is -2 to the third? That's what I heard. What does -2 to the third mean? To me, I see 3 negatives makes the answer, and 2 times 2 times 2 is 8. I lose anyone so far? What is -2 to the fourth? That's what I heard. What does -2 to the fourth mean? I see 4 negatives. 4 negatives makes the answer a positive. And 2 times 2 times 2 times 2 is 16. What is -3 to the fourth? It actually is. I thought you were going to stick with it. It is -81. You're like, why? Your calculator was right. And that's okay. You need to agree with your calculator. This should make sense. What's being raised to the fourth power? Not the negative this time, right? This time the negative is on the outside. And all we're raising to the fourth power is the... If you want a number with that negative, put a 1 there. It's -1 time. But the idea is that negative is not being raised to the fourth power, right? So I know 3 times 3 times 3 times 3 is 81. But how many negatives are there then? Only 1 makes the answer negative. Does that make sense? What is -2 to the third? A lot of people will just go 8. Is it right? Is it this? Did you just make them both positive? Don't do it. It's a trap. You've been warned. Okay? This is negative times what's being raised to the third power? How many negatives are there? That's why the answer is positive. Not because these canceled. If this was check right now that you can get the answer -16. Do not just cancel those negatives. Write out what it means. Verify you can get both of those answers. Keep track of your negatives. Now we're on PEMDAS. What are you going to do first? What is 5 times -2? What is -10 plus -10? A negative plus a negative combine to make negatives. You're like, I thought it was positive. That's multiplying. Be careful. Differentiate when you're multiplying, when you're adding. Just like if somebody said, what's 5 times 2? And you yell out, 7. He's like, what the heck? Come on, we're multiplying, we're not adding. This should stop you the same way. It's a different set of rules. Make sense? Start with what on example 6? What is negative 3 times 2? Can I do that division? Definitely before we're doing adding and subtracting, this is the multiplying. The dividing is separated. You actually can do it right now. What is 10 divided by 2? If you think about it as a negative 10 divided by 2, it's still negative 5. Just be careful that that 5 stays negative, okay? Now we're left with adding and subtracting. I can type all that in, hit enter. I would combine the negative and the negative. What is negative 6 minus 5? Yeah, because I think of that as negative 6 plus negative 5. What is negative 11 plus 4? What is 5 times negative 2 to the third? Plus 2 to the fourth divided by 4. This to me says 5 times I heard negative 40. There were 3 negatives. 5 times 2 times 2 times 2 is 40. Plus 2 to the fourth is 16. What do I do next? We divide before we add. So it's negative 40 plus 4. Negative 40 plus 4, combine or cancel, leaving us with what is negative 5 times 3 to the third? I'll give you a hint, it's big. So it's basically negative 5 times 27, or you said negative 135? Yeah. Okay. What we do is we deal with the top and the bottom separate. We've done this before. So now on the bottom, what would I do? Can I do anything more to the top? Negative 135 divided by 3 should be negative over 2 plus negative 10. Can I divide that 8 into the 45? It doesn't go in evenly. So is that my answer? Do I circle it?
No.
Unfortunately not. What do you have to remember? What is a negative divided by a negative? So even though the 8 won't divide into the 45 any easier, or and make it any simpler, we write that answer as positive 45 over 8, or 5 and 5/8. Last but not least, distributing. I don't need to cover this. This we already covered. 5 minus 10 is what? Sorry, I'm merging some notes together, so there's some extra stuff here. So if you need to, we can talk about these. Here's where we do need to talk about this. What does minus and negative become? This is where I told you you have to know how to change those. You have to know those rules to change them, because now what's negative 3 plus 2? On example 3, before I can combine like terms, what do I have to do with that negative 2? There's a D word. Does it keep going to the 4? only across the group. At this point, am I adding, subtracting, multiplying, or dividing? Multiplying. So in my mind, I'm using the rules of multiplying, right? What is negative 2 times positive 6? Oops. You said it right, then I wrote it wrong. So I heard negative 12x. What is negative 2 times negative 3? Bring down the plus. Anything else clean up? So negative 12x plus. On this one, what distributes? Now this gets a little trickier. I don't think it's going to be this hard in the homework, but I wanted to kind of get into this. We, at this point, are multiplying, right? What is 3 times negative 1? But this is x times x. What is x times x? This is a little harder than what's in the homework, but it has a purpose, so just stick with me. What is 3 times, what's the number with the y? What's 3 times 1? And x times y just stays xy. Why do I have this example? Because what can I do at the very end? Combine. What is negative 3 plus 1? Plus. Did the exponent change right here when I added? It never does. Don't start changing it. When does it change? If I'm multiplying an x times an x, the exponent becomes x squared. When I'm adding x squared and x squared, the exponent stays x. And the last thing we're doing here is we are just substituting. So for this one, it looks like everywhere there is an x, we put a 3. Everywhere there is a y, we put a negative 2. Be very careful with your variables on this. So this ends up being what? 3 times y, or negative 2 squared. Notice the 3 is not being squared, just the y. Minus y minus a negative 2 plus 4 times x, 4 times 3. Make sure I highlighted those. All right. So do not make this negative 6. Order of operations, we have parallels. We do the negative 2 squared first. This literally means 3 times negative 2 times negative 2, or 3 times 4, which is 12. Minus negative 2, we change that. Minus negative 2, we change to a plus 2. And 4 times 3, we change to a plus 12. So now we can add these straight across. 12 plus 2 plus 12, about 26. Last one, 3 times y. 3 times our y is 15. Minus 5 times x. X is negative 1. Over 4 times x, 4 times, negative 1. Everywhere there's an x, we put a negative 1. Everywhere there's a y, we put a 15. Now we're just left simplifying it. 3 times 15, about 45. Minus 5 times minus 1. Negative 5 times negative 1. 2 negatives multiply and make that. All over. 4 times negative 1. We can simplify 45 plus 5 to give us 50. But 50 divided by negative 4, I'd be okay if you want to make that a decimal. You could divide that in, and that would give us, I think, negative 12.5. They're probably going to want us to leave that as a fraction, though. So we need to simplify. Top and bottom are divisible by 2. And we could get 25 divided by negative 2. But we would not leave the answer like that. We talked about it earlier. We do not leave the negative in the denominator. Basically, we bring that up to make that negative 25 over 2. Or negative 12.5. Or if they wanted a decimal, negative 12.5. Do not leave that negative in the denominator. That would not be correct. You need to make sure that negative makes it either to the top or to the side. You could make it negative, and then 25 over 2 would also be fine.